All right, I think it's about time. How's everyone doing? So I'm Josh Kaplan. I'm a Senior Program Manager on Azure Analysis Services. And that's what we're going to talk about today. I'm going to try to keep this session a bit balanced. I'll talk about what is Azure Analysis Services, but also a little bit of the why to use it, some of the how to use it. And then I'm going to do a bunch of demos, and I'll show at least 3 new features, which I think are pretty big features that have yet to be announced. And I'll do those all through demos as well. So real quick, do a little, I'll use the right computer to start with. Do a little BI survey. How many people out there right now are using Power BI? That's a good number. How about Tableau? Excel? Usually that's the whole room. So all of these work with Azure Analysis Services. All of these and a bunch more will work with Analysis Services. Is anyone using this with Analysis Services or Azure Analysis Services today? Cool. Has anyone just never heard of Analysis Services? Okay. Cool. So all these work with Azure Analysis Services. Now all those tools can also directly go and talk to the data sources that you see on the left-hand side here and many, many more. They can go talk to them directly. So why would you want to put Analysis Services in between those tools? In between those tools and the data sources? There's 2 reasons I like to talk about. The first is this rich semantic model. When you go and you connect to a SQL data warehouse or just any data warehouse really, the data is usually stored in a way that, that was best for loading that data. It doesn't have any business logic built into it. It's not usually business friendly. A user would log in with, say, Power BI to start creating a new report, and they'd get a list of tables. Those tables may or may not have friendly names. They'd have to figure out what those tables mean, how those tables relate together, and then once they figure that out, how to actually query those tables, whether it be how do I write SQL, or if I know how to write SQL, how do I write the right query to get the right number back? Everyone's probably been in a circumstance where they walk into a meeting and there's 2 people in there supposedly reporting the same revenue number, but they have different numbers because they calculated them differently. So with the semantic model, you can build all this information into the model. So when a business user comes in, they connect with Power BI, they see friendly information. They see stuff they can recognize. They see calculations already pre-put in there for them, so they can just drag them on and start using them. Also, you can incorporate your security model in there. So users only see the data that pertains to them. This means with all these tools, they can just connect and just start building reports, not have to worry about how to extract the data and how everything works together. The other reason to use it is these lightning fast queries. So in between your data sources and your users, you put Analysis Services, and it gives you that model, but it also gives you this very fast in-memory caching layer. So Power BI is kind of intense. It sends a lot of queries. Every visual you put on there will generate at least 1 query. Every filter you put in the filter list will generate at least 1 query to populate those drop-downs. Every slicer will do the same thing. And every time someone clicks, it'll fire off n number of queries based on what you have on your report. That's pretty intense. And users generally expect those to come back within a second, maybe around a couple seconds most. Or things start to spin and it's not a great experience. So that can really hammer your database. And business users typically look at a higher level of data, especially to start with. So you spend a lot of time taking a bunch of data that's in your database and then just aggregating it up. And then for the next user, taking almost the same data, aggregating it up again, but putting a little different spin on it. And by caching that data in memory, you can reduce the load that you put on that goes onto your back-end databases, and also give your users a very, very fast experience and a very good experience. So let's actually take a look at that real quick right now. This is Power BI Desktop connected to Azure Analysis Services. So when you first connect, you will basically be taken to the report page, and you will see the model instead of just tables in a data warehouse. So if I want to, in this model actually contains a bunch of trip information. Trips for New York City taxi cabs in New York. Where people were picked up, how long the trip was. And if I want to see just a total number of trips in New York for the period of time that this was taken, all I need to do is go to the trips table, and I just have a trip count measure. I don't have to know how this is calculated. This happens to be a count all rows that are in the trip table. And I'll just drag it on here. And in that split second, it ran a query out to Azure AS up in the cloud, counted all the rows in that table, returned the results back. And just to make it a little bit easier to see, there's over 10 billion rows of data in that table. This is not small stuff. So let's make some more room. And what's nice about when the data is this fast, you can start to ask lots of questions of it. And this is something we'll typically see users do. They don't start from a very specific query because they need to make sure their query runs efficiently and they get something back that they can then go run again. Typically, we'll see users pick a metric, drop it on there, no filters, no nothing, scans the entire database, just like I did there. And then they start to kind of mold it into something that they can use. So as you're looking at the data, you can change the query, change things up so that the data starts to resemble the question you're trying to ask, and you can use the data to guide you into finding the right answers. So let's look at New York, lots of trips, obviously. Let's look at where these trips are occurring from. So I'm going to throw on here the pickup location. And every time I'm clicking, it's actually firing off queries and scanning those 10 billion rows. So it took all those 10 billion trips and just plotted them on a map. And it's 10 billion trips, so it's a lot of dots. Is that green? Blue? There's a lot of colored dots. So, not the most useful. I can start asking some more questions. Let's see, where are the most popular places to pick up passengers? If I'm going to start driving for Uber, where should I go? Where will I make the most money? Where should I wait for rides? So let's take the revenue per trip, which again, the formula for that is predetermined for us. I can go and drag that on here, scan that 10 billion rows, boom. And we'll take the top 10 pickup locations and drop that on here. So there's 2 locations in New York that are pretty popular for at least pickups. Any ideas what those might be? I heard airports. Well, if we don't know for sure, what we can do is we can click on one of them. And when I click on one, it's not going to run one query. It's going to run 2 queries. One filtering down the map, one filtering down this little guy down here. And it'll do that all in a split second. And yes, you'll see the first one, excuse me, is JFK Airport. And New York has 2 airports, so next one will be LaGuardia Airport. And LaGuardia is very popular. You have to line up on the highway if you want to get a cab. So it looks like the revenue per trip, I can make a little bit more money per trip if I pick people up at JFK Airport versus LaGuardia. But will I make the most money there? Let's ask some more questions just to find out. Let's take our trip count measure that we looked at before, drop that back on here. And this time, let's slice it by the trip duration. Flip it around, make some room for us. This will show us the number of trips by the kind of the length of the trip. I'll zoom in case you can't see it. Now, by default in Power BI, when you click on something, it does what we call a cross-highlight. It kind of shows you the percentage of the total. So you see kind of there's like a little bit of green at the bottom, and there's a grayed out bar on top of that. It's basically showing what part of that bar is made up by what I just clicked on. So for this question, it's not very useful. So we can actually change the behavior here. So what I'll do is I'll say edit interactions, and when select that real quick. When something's clicked on here, instead of cross-highlighting it, I want it to filter. So now when I click on here, we can easily see that the majority of trips from JFK are in that 30 to 45-minute range. JFK is kind of out there. Versus LaGuardia, where the average trip time is going to be 15 to 30 minutes. Every time I'm clicking here, it's running 1 query, 2 queries, 3 queries. I've seen people go up to like 30-some queries, maybe even more on just one page. And because the data is so fast, we can ask these types of questions. When I first started doing this demo, I kept pulling the wrong fields in there. And there's a good video of that on Channel 9. But as I would do that, I could actually see very quickly I made a mistake because the data didn't look right. And I could pull a field back out and put another one in there without losing a bunch of time. And that data actually guides you to finding the right answer, in this case, the right presentation here. So that is just querying analysis services. Now, how do we go and make one of these models? That's not how. Anyone remember this? I know now it's kind of been a while. This is howol.net. You would upload a photo and it would tell you, it would try to detect your gender and tell you your age. I worked on this. This was originally a demo for Build. It was like 4 years ago now, for Joseph Sarush's keynote. And I was on the demo team for this. The whole point of the keynote was, all right, we'd show off these new APIs. We'd then also capture like the web telemetry of people who were uploading the photos, and we would send that to Azure Stream Analytics, and then we would go do some aggregation there, and then stream it to Power BI all in real time. You'd see the Power BI dashboard kind of jump and move around. Most people don't remember the Power BI part of that because this pretty much took off. But I used to do in my demos, I would go and show the streaming aspects of this when I was on the Power BI team. But we would actually fork that data as it was going through Stream Analytics. So Stream Analytics, excuse me, lets you have multiple outputs of the same data. So we'd send aggregate data over to Power BI so you could see the summary data in real time on the dashboard. And then we'd also go ahead and pipe the more detailed data, the more lower grain. It's not much more detail, but it had much more time grain in there. And we'd pipe that over into a blob store, and we'd use Data Factory to turn that into a data warehouse that we could go and then report off of. So I've never really shown the data warehouse piece of that before. I'll show that now. I'll actually go build a model on top of that. So to get started, you can go to the Azure portal. If you don't already have an AS server, they're really easy to create. You just do the plus new here. And under Data and Analytics, you'll see an option to create an Azure Analysis Services server. Now, you'll be asked what size of server do you need. Generally, it doesn't matter when you're starting out. If you decide you chose wrong, you can always kind of scale it up. Just note that the features are a little bit different between the B and S SKUs. The B SKUs don't let you do some of the stuff I'm showing. But if you really want to start something out and you want to start small, but you want to have all the features, start with one of our D SKUs. Those are really good for getting started. So once you have the server, you'll be on our overview page here, and you'll see our new web designer tool here. You can open that by just clicking here. And this will allow you to start building stuff in the web. We also have a Visual Studio tool, which is kind of our more mature tool. It's been around for a long time. And that will also let you build models there as well. I'll start showing how you can do it from here, though. So to go ahead and create a new model, you can just say Add. And you'll see a couple sources come up. You can connect to an Azure SQL database, an Azure SQL Data Warehouse. If you have a Power BI desktop file that has data in it already, you can actually upload it from here, and we'll convert it into an Azure Analysis Services model for you. And then you can start using that instead and use that as your starting point. But I have all this howol data. It's in a SQL Data Warehouse right now. So I'll name my model. And I'll pick SQL Data Warehouse. We'll show you all the data warehouses that you have in your subscription. Excuse me. You can also choose to pick a different subscription if you want to. But I'm going to find the one that is howol telemetry. It'll pick my database for me. I'm just going to put my connection information in. See next. And then it'll show me all the tables in there. Now this is kind of a laughably small data warehouse. Typically you'd have dozens or even sometimes hundreds of tables in there. Just for time's sake, I'm keeping it small, but you can see there's some staging tables in here, and then there's some real dimension and fact tables in here. I'm just going to go select the tables that I want to include in my model. So our fact table, and I have 3 dimension tables here. I'll say create. And this will go ahead and create the model for me. And after the model is created, we can actually go ahead and just start querying it live. So here's our fact table. I'm going to take the session ID. I'll drop it on here, and I'll just run it. So what this will do is just give us basically a count of the rows that are in this table. And almost 6 million rows in this table. Sorry, 600 million rows of data in this table. So it's a pretty big table. And this actually ran in our direct query mode. So we didn't spend the time to pull this data into cache right away. We can go ahead and do that later. So when I ran this data, it didn't hit the in-memory cache. What it did is it actually generated a SQL query and ran it directly on the data warehouse. It's really good for getting started. It's really good if you have a low amount of concurrency. But when you start to have lots of users building lots of complex reports, you're going to want to switch that into cache mode and make sure you cache that data. Another thing with SQL Data Warehouse is it doesn't actually include relationship data in the database itself. So we actually have to go, if I want to query across tables here, I actually have to go and define those relationships. So I can switch into the model view. And in the model view, we can actually start building out our model. The nice thing about this model view is if you have a lot of tables, you don't have to display them all at once. You can kind of drag them in as you need them. It's not as useful with 4 tables, but with 40 or 140, it's very helpful. So here's our fact table. I can bring in our browser dimension. I can bring in our, not our photo fact, our OS dimension, and submission method. This is how they uploaded the photo. Did they actually upload the photo? Did they do what I did where I picked one that was already up there, or did I search on Bing? And I can draw the relationships between these. So browser ID goes to browser ID. I want it to be an inner join. Save it. And then I can do OS ID to OS ID. Save it. And the last one will be submission method ID, or really ID, and save it. If the relationships were in the database, we would have brought them in for you automatically. Once you get a layout you like, you can go ahead and save that layout so you can kind of revert back to it. I've often come in and I'm trying to troubleshoot a relationship, and it's really hard with all the tables on there, so I'll go ahead and I'll actually close out all the tables, and I'll bring on the 2 tables that I'm trying to debug the relationship between and try to see why it's wrong, what's missing. And then when you're done, you can kind of revert it back to that saved layout. So we have a model now with relationships. This now means that I can go ahead and say, okay, take face count, and maybe I'll break that down by the different submission methods. And now we can join across tables when it generates that query. So we have a working model. This could be as far as I need to go, but it's kind of an ugly model. We got a bunch of IDs in here, primary keys, foreign keys. User should never use these. We got the relationships in there now. We got some unfriendly names, so we can go ahead and clean that stuff up before we open this up to a bunch of users. The easier it is for your model to use, the less your users come to you asking you how to use that model. So the more business logic you can bake in here, the easier it is for people to get started, and the easier it is for you to focus on building more models or work on different tasks. So go back to the model view. Let's get rid of all these primary keys. This is the first time I've done it on such a small screen. I will get rid of all those keys, ID columns. We'll come back over here. Let's get rid of the foreign keys as well. And basically anything else I don't need to see. That looks good there. And I can just set the hidden property here to true, and it'll basically set that property for all the columns on all those tables. Just for the sake of space, move this back over here. So now those columns are hidden. I can flip back to the query view, and I only see more relevant stuff in those tables. Still not the best looking model. So I'm kind of a stickler for the names. That the names are, if things are named well, people can find them more easily, people can use them more easily. So I'm going to click on everything here that I want to change the names of. I hate things that don't have the spaces and things that are synonyms. These are basically the names of the columns as they were in the database. Now, the person who was building the data warehouse was not necessarily thinking of hundreds of business users coming in and building their own reports on top of that. So it's nice to put in really friendly names. So I can say, now edit all those names. I come in here, photo fact, I'll put some spaces in. OS, operating system. Browser name, put a little space in there. Method name, and operating system name. So this will update all those names all in one transaction. And our model's starting to take a little bit more shape here. a little bit more shape here. Here. Anyone know any good jokes? There we go. So, yep, starting to look a little bit nicer here. I can also do some things like let's add our measures to here. So these are those pre-calculated, or not pre-calculated, predefined formulas that users can come in, just select them out of that drop-down list, like I was doing trip count in that taxi demo. I can put those in here. Important note, if you're going to use Excel with this model, you must have measures in your model. Otherwise, there's not much to calculate there. Power BI gives you some options to use existing columns and do aggregations on top of those. But so on our fact table here, I'm going to say measures. Let's say add. And let's do total faces. I'm going to create some simple measures. There's definitely much more interesting stuff you can do than this, but I'm going to do some simple ones for time. We'll do total faces. That'll be face count. Let's do average number of faces. Put our face count in here again. Let's do, and we're building the list out as we go. Let's do, excuse me, total processing time. Average processing time. And for completeness, I'm going to do two more. We'll do total image size. And we'll do average image size. Average image. So I have 6 measures here. I'll go ahead and create them, and they'll all get added to our model. And they'll show up for users to use. So you can see them kind of down here. If you have a table that still has a bunch of columns, you can go ahead and organize a little bit further. Like I don't need these columns anymore because we made measures out of them, so I'll hide them. And then we can also kind of group these things into folders, all making it easier to find what you need. So I can take my measures. If I want to put all my measures in one folder, you can select them all, or you have a little handy thing here that lets you select all the measures at once. I'm going to put them in a folder called metrics. I'll apply to all those selected measures. Let's also go ahead and put all the session information in a folder called session. And finally, location information in a folder called location. As I make all these changes, you can keep flipping back to your query view to see, kind of preview what this will look like when users use it in their tools. So if you use this in Power BI, this is basically giving you a preview of what it'll look like. So you see our folders here. It has all our measures in it under metrics. And I can go and I can query it here, or I can start using this for real in Power BI or in Excel or any other tool. So to make it really easy for you to get there, you can click Open in here, and you can just say Power BI Desktop. That's going to generate you a Power BI Desktop file with a live connection back to this model we just created. And loading. Not loading. No, it did load. It asked me to log in. And you'll see that model we created right here. You'll see our display folders that we created. And just like before, I can go ahead and start using this. So let's take total faces and maybe average image size. Let's slice that by the submission method again. And the model just works. Let me convert this over to a table real quick. Zoom in a little. Works. Formatting is not the greatest, especially for whole numbers. Desktop did a nice job of trying to guess what they wanted my decimal numbers to look like. But I can actually go ahead and fix this too, so I can actually make it so when people start building reports, everything's formatted right, and that's reusable across every report they go and build. So to change that, I can come back in here, Go back to model view. All my whole numbers, which are the total measures, I want them to have a comma after the first 3 digits. And then all my decimal numbers, my averages, go a little crazy. Let's give them 4 decimal points. So I also want them to have a comma, but then after the decimal point, I want to have 4 points. Apply. Now I can come back here, refresh, and you'll see the formatting has automatically been applied here. So now users just come in and start building the report. It'll look nice, and hopefully it's easy for them to navigate. Same work that we did here, not only is useful in Power BI, but then in Excel. We can say open up in Excel. So then, again, generate the file for you so you can just get started with it. And in Excel, it'll look a little bit different because it's the field list in there is a little bit different than the way it looks in Power BI. But you'll still see the similarities from the work we did. There we go. You see our folders that we put in here, and I can still grab what's total faces, drop it on here in our pivot table, and still get that formatting. The same stuff we did is reusable across multiple tools. So you get a consistent view not only of the metrics in your data, but also the formatting and everything and how it looks. So that's basically building a model. A couple other things to just note real quick. This tool is still developing. If there's things in here that you can't find yet, there's stuff in the model you want to do that's not yet in here, you have a couple options. One is you can view this as a script instead of a diagram. And in the script view, you have access to all the properties. And you also have full IntelliSense here. So if I want to just change this from direct query mode to import mode, I can see the different options for there and switch to import. Everything is accessible from here. You can also check these into GitHub and read them from GitHub if you want. And you can also go ahead and open this up in Visual Studio. And what we'll do in this case is we'll generate a Visual Studio project for you. It'll basically open up Visual Studio at the exact moment you left off here. And you can do all the functionality that's in Visual Studio. You can do it right there, and then you can post it back up to your server when you're ready to deploy. So that's building a model. Just some considerations when you're going to use analysis services. If you're trying to compare between building models in Power BI versus do I want to go ahead and do them in analysis services. Analysis services, we love small models too, but we're really good with large models with high concurrency of usage. The queries are really fast, as you just saw. Everything's still 100% in memory. We don't page anything out. So when we say it's in memory, it's actually in memory. Every query is going to scan that in-memory data. You can refresh this data on demand. So whenever you want to update that data, you can call a refresh on that cache, and that cache will be reloaded. And to help you with larger models, which is what I'll show you next, we have data partitioning. I'll touch on that more in a little bit. The largest SKU size we have for Azure Analysis Services right now is 400 gigs, and that's after that data is compressed. We have a lot of different programmability options. I'll also touch on those. And you saw the web designer. We also have Visual Studio. We have we also have other different integrations with source control, like the GitHub integration. So let's talk a little bit more about loading data. If you're not familiar with the tabular object model, basically starts out like this. You have a model. That model might have data sources. Probably has data sources. Probably has tables. And we'll have relationships between those tables. And a few other things. Within a table itself, tables have columns. Tables have measures. Tables have hierarchies. Tables also have partitions. Now, if you're using Power BI, you're going to have one partition. Kind of something like this. So that partition will be whatever would load all that data for that table. You could, when you're designing your queries in Power BI, you might specify some filter on there. You'd see that filter in here. You might specify some transformations. You'd see that transformation in this query. But when you want to go and reload your model, if you don't add extra partitions, you will always reload that entire model, at least that entire table, every single time. So typically, in analysis services, what you do on a fact table is you'd add multiple partitions. So for starters, I would change my first partition to have some sort of filter on it. So maybe I want to partition my data by day. So I'll have that first partition filter down to just day, to 1 day, 1/1/2017 in that case. And I can load that day. Now, tomorrow, the next day comes around. I can add a new partition for the next day. And I can process that partition without having to reprocess the partition that came before it. And I can go ahead and add a third partition and do the same thing. And I can keep adding partitions, incrementally loading data without affecting the older partitions. And as I can incrementally add data, I can also incrementally drop data by just dropping old partitions when I no longer need them. This allows you to process that model without having to reload the entire data every time. So how do we do this? There's a couple ways to do it. The manual way, which if you are in SQL Server Management Studio, you can connect to your server, you can find the table you want to partition, you can right-click it and say partitions. And this will show me, okay, this model has exactly one partition. In that partition, I can see the query for that. If I want to go ahead and add a new one, I can just copy that one and change the query to be my second day. This one is specifically for 4/27 in 2015. I can do that manually. Usually, you automate all these steps. You'd have some production job that's running that would, not only ETL stuff into your data warehouse, but then trigger the refresh of your model when that data is ready to be consumed. So to do that, I wrote a little sample here. And this is using our .NET library. It's called AMO. You get it when you install Management Studio. You'll see the binaries in there with it. You can also download it directly when you go and go to our doc site. You'll see it in there as well. So in this is a little console app. And I referenced AMO right here, specifically the tabular part of AMO. And what I'm going to do in this sample is I'll create a partition. And then I'll process the partition without affecting the other partition that's in there. So I set up a connection string to our server. And we'll connect to that server. Now, little older terminology, we call models is what we've been referring to. But models actually wrapped in something called a database right now. So we need to find the database. And the database was, let me jump back here. How old? So I can find that database by name here, how old. Now we have a reference to that database object. In the database, in the model, there's a tables collection. We're going to find one specific table called PhotoFact. And then we're going to start creating a new partition. So I'll create a new partition. I'm going to name it PhotoFact 2015-04-28. It's going to have this source query, where it's basically the same query you saw in the other partition that was there, except it's filtered for the 28th instead of the 27th. And then we're going to add that partition to that table. And then when you add it to the table, it just adds it in memory. To actually send it to the server, you have to call update on the database, and it will make the changes to the database. So let's run it down to that breakpoint. Interesting thing to note here, notice it popped up the Active Directory sign-in screen here. By default, when you're using Azure Analysis Services and you're using AMO and you just say connect the way I did, default behavior is going to pop up this dialog for you. It's great for a console app when someone's actually sitting here. Not great if you're automating it in some sort of process where no one can see, where no one's actually there to interact with it. A couple things you can actually do there. Let me stop this for a second. On the connection string itself, you can pass in some credential, like a username and password. If you're not using multi-factor auth, recommend you do use multi-factor auth. You pass in like a service principal, which is kind of like a service account for Azure AD. It's more It's not tied to a user, it's actually tied to an application. Or if this is running in a Windows process, like in this case, it's running on my machine, which is running under a Windows process that I'm logged in as, and my company's directory is synced up to Azure Active Directory, I can add here integrated security. This is on the connection string equals SSPI. And what this will try to do is impersonate the Windows identity. Basically, we'll go take the Windows identity and exchange it for an Azure Active Directory identity, and it'll work without having to pop anything up. This is great if you're running something in like a service, or if you're running stuff in SSIS, and there's a run as account on there. Put that in there, it'll use the credentials of that account. Not great if you're doing something like Azure Functions, which does not exist in any kind of a domain. There you'd want to use something like a service principal instead. We have a blog that came out recently showing how to do that. I want to take this out for now. I'll show the AAD way. And we'll run it down to that breakpoint. Connects, creates a new object, hit our breakpoint. Come back to our SSMS screen, hit refresh on the, just refresh the list here. You'll see our new partitions created. And you'll see it has the filter for the 28th on there instead of the 27th. Now you want to go ahead and process it. And that's what this next line does. The next couple lines. Recall here on that partition, we still have that pointer to that partition we created earlier. I'm going to request refresh of type full. And again, I have to update the database for the changes to take effect. CF5. Now this is a synchronous process. So if I was to close this app right now, that processing would fail, as long as I did, if I did it while it's still running. So important to note that if you're going to process in Azure Analysis Services, you must keep that connection open while the processing is happening. So if you're using something like an Azure function, by default they time out after 5 minutes. If you're going to run longer than 5 minutes, you're going to want to upgrade to an app service plan that can basically run as long as you like. But something to keep in mind, you need to keep that connection open while processing is running. So this is complete. Come back here, and I'll refresh. So notice the last process time on the previous partition and the new partition. I'll refresh this again. You'll see the new partition was updated, and the old partition wasn't. So we basically just incrementally loaded just those new rows. So processing, a lot of detail to it. This is one solution that's up there that uses Azure Functions. Christian Wade over there wrote a nice white paper on how to automate partition processing. Gives lots of good examples. Also has a lot of good code samples in there. Go to aka.ms/AS processing. You can read all about it, use those code samples, and that'll really get you started. Now I mentioned that processing is a synchronous call. Got to keep that connection open. No matter if it takes 5 minutes, 5 hours, 10 hours. That's true for now. But coming soon, we're coming out with a new management API. These are the first set of commands that are coming out. And it'll be a RESTful API, so it won't require .NET. And it'll give you async capabilities, so you can actually start to call process asynchronously. So the way this works, the first really 2 sets of APIs are coming out. First one, sync. Don't worry about that yet. I'll explain what that is in a moment. And then refresh. So similar to the way the Power BI API works, any name that has an S on it is a collection of objects. You call get on a collection of objects. It gives you a list back. So in this case, if you call get on refreshes, it'll give you your entire refresh history. And if you do a post on an object, it will create a new object. A post on a collection will give you a new object in that collection. In this case, it would start a new refresh. When you start a new refresh, after you call that post, we give you back a location header, which will give you the ID of the refresh that was created. You can call it get on that ID, and that will give you the current status of that running refresh. You call delete on that ID, it'll cancel the refresh. So let's look at an example of this real quick. I'll use the same sample here. And I'll call a different method. So in the async call here, I'm making an HTTP call. And ignore the endpoint right here for now. That's still haven't deployed to this production yet. It's coming in the next couple of weeks. We go to the server's endpoint. I'm going to the server that I was using. And then there's the models collection. I'm going specifically to now the AdventureWorks big model. I'm going to add to my request. I'll start building my request here. I'm going to add to that request the content type of JSON, application JSON. I'm going to add an authorization header to it, which is just an AED bearer token, which will be my identity in this case, is the way I set it up. But that's how we'll authenticate with the API. And in the body of the request, I'm going to put a refresh body in there, a refresh request body. So I'm going to request of type full. This matches all the types that you see in SSMS when you say process, or you see in AMO when you say process. So full, process data, process defrag, merge. The options are all there. I can say how much in parallel I want to do. And I don't have it in this example. I can also pass in a list of objects I want to process. So if I don't want to process the entire model, I can say just process this partition or this table. In this case, we'll go ahead and process the entire model. So we're going to go ahead and post. We're going to add on refreshes to the end of this, end of that URL that's up here. And then we're going to go post all that to the refreshes endpoint. That'll give us back, if it's successful, it'll give us back a location header on the response. That location header will essentially be this, plus the ID of the refresh that was created for us. So from that point forward, I could close the application and it would still continue to run. Or I could do what I'm doing here, which is I'm going to keep polling to see if it's done. So here every 5 seconds I do a get on that location header we got. So a get async on the location header. And that'll tell me what the current status is of that running refresh. And I'll do it every 5 seconds. So let's go ahead and run this. Log in. And in a second, we'll see the first response back. So right now, it's pending. It's been submitted, but it hasn't started. And now it's started, so you see the status is in progress. Refresh type is full. And it lists out all the objects. It's a really simple model. It has one table with one partition. But you can see that that partition is in progress. It would list out all the objects that were being processed if there were more in there. And like I said, I can close the console app at this time. It would continue to run. I can come back and see the status. So this will let you actually go ahead and do a lot of things you couldn't do before. But the biggest thing is you now no longer have to maintain an open connection when you're trying to process a long process for a large model. This will run for a little bit, and eventually it'll come back, say done. If there's any failures in here, let's say maybe my database was offline, you'll see it'll come back failed. You can set retries, so you can say retry 3 times if you want. But if it fails, it'll come back failed, and it'll give you the error messages in there for which object failed and what the reason was. Instead of giving you a list of 50 we canceled the operation things and 1 correct error message, you'll be able to find the right error message in there. So I'll let that keep running in the background. We can kind of move on a little bit. This is coming soon. All right, so how do we scale out? Let's say I have a model. I designed it really nicely. So easy to use. Yep, question? Question is there a PowerShell option? Yes, there is a PowerShell option as well. That is still synchronous. We'll have to start updating those to add the asynchronous options to it. But yes, there is a PowerShell option. There is a blog post on that recently came out, and I think, Christian, you're going to demo that? He will demo that tomorrow. So scaling out queries, you build a model. It's really easy to use. Became really popular in your business. And now every Monday morning, people are coming in and say, okay, what are my sales for last week? And they're all hammering that server. I took this slide out of a presentation I did in like 2008 or 9 at TechEd for how do you scale SQL Server Analysis Services. So what you'd do in a case like that, in a scenario like that, if I was using SQL Server Analysis Services, is I would get another server. I'd set it up behind a load balancer. I'd copy my database over to that server or n number of servers. And through that load balancer, it would kind of distribute the load across them. A lot of work to do, but it does let you kind of almost infinitely scale out as your users grow. You can keep adding more and more query replicas, and you get more and more users in there. In Azure Analysis Services, we haven't really made this possible for you. There was kind of two reasons you would do scale out for SQL Server Analysis Services. One was the concurrency thing I mentioned. The other would be like a high availability. In Azure Analysis Services, we never really gave you the ability to solve the concurrency problem. We did, however, take care of the high availability situation for you. And this is kind of a real high-level architecture of Azure Analysis Services. We have these front-end nodes where requests come into from different users. And then what we do is we direct that to a back-end node where your server is actually running on there and your model is running on that server. If that server has a hardware failure, needs to have the OS upgraded, or for whatever reason goes down, we automatically move you to a different server and just redirect the user's queries to that server instead. But what we never let you do is have multiple copies up and running at the same time. So we have a new feature coming out really soon that'll let you do this really easily. And essentially, we took our inspiration from Azure Websites here a little bit. To add query replicas, all you have to do is change the number from 0 to the number of replicas you want. And what we'll do is we'll automatically add those replicas for you and distribute the queries for you. And you get really busy on a Monday. A lot of times that drops off on a Tuesday maybe, or maybe on Wednesday, and it's quiet for the rest of the week. So you can turn that number back down to 0 if you want, or any other number, and we'll pull those replicas back in for you. And you go back to just the small amount. So you no longer manually have to set up a load balancer to make this work. It'll be taken care of for you automatically. So let's actually show that real quick. And this finished. So this is a dev build of Azure Analysis Services. Hasn't quite hit production yet. But a couple things you'll notice. You now have two server names. The first one is the same one you have today, and this one you'll use for querying. So anyone who goes to this endpoint, if you have the scale-out options turned on, will be automatically load balanced across all the different replicas. The second one you would use specifically for management tasks. So if you're connecting with SSMS, you're going to call those processing commands I was showing, at least through AMO. You would connect to this endpoint. That way you're always assured to hit the server that actually lets you do writable changes to it, where everyone else will get automatically load balanced across the query replicas. Then, Monday comes around and your load is getting really heavy, and you need to add more compute power there. You now click on the scale out option, and you just have a slider here. So I'm really busy. I want to add 4 replicas. I just slide this up to 4, and I can save it. And it will go ahead and just start scaling out. What it'll do is behind the scenes, it'll spin up a bunch of extra servers, and then it'll copy your database to all your databases that are on that server to all those different replicas. There's another option here that lets you separate out your query server. So I added 4 replicas here. Technically, now I have 5 places where things can be queried from. The server that's writable, that I use for processing, and then the 4 replicas. By default, all will be used, but you do have the option to say, okay, I want to separate out the one I'm going to do processing on. So when you turn this option on, essentially you only load balance your queries across 4 servers, but you have one available still for you to do processing on. You can check things out, make sure they're good, and then there's a sync command you call that will go and push it out to all the other servers. That was that other API that I referred to when I showed the other slide, the other REST API. We call sync. It'll go and replicate those out to all the other query replicas. And all these commands, the scale up, scale down, they include the processing server in the query pool, All these can be done through ARM as well. So you could go ahead and choose to decide that I have 4 query replicas. I'm going to include my processing server in there, so I have 5 total. But when I go to start processing, I'm going to programmatically take my processing server out, process, sync it, and then put the processing server back in. So I go from 5 to 4 back to 5 without affecting kind of the user's performance, query performance, and without them seeing new data maybe before it's ready. It basically makes it a heck of a lot easier than it was when you had to go set up all this stuff yourself. Tuesday comes around, not as busy. Just bring it back down, save it, or again, programmatically do this, and it'll go back to just 2 replicas. It's really that simple. I'm going to show one more yet to be announced feature, server aliasing. So when you connect to Azure Analysis Services now, you put in that server name that I was actually showing in the portal. Typically, people would use some sort of alias for their server when it was on-premise. You don't want to necessarily put the actual server name in the connection files because sometimes you change servers. Sometimes you purposely want to move people somewhere else. And sometimes those names are just hard to remember. So you want to put something a little bit more friendly on there. That to date has also not been possible with Azure Analysis Services. But we've introduced a feature. It's kind of half rolled out there yet. It doesn't yet work in the Power BI service. We're working on getting that working this month. September, next month. And we call this our link option. So you can actually create link endpoints that can be any name you want, basically any HTTP endpoint. It could be contosodata.com or whatever you want to come up with. In this case, I just used an Azure website. And all that endpoint needs to do is return the text of the real server name. And then when you put this in your connection string, in the desktop, Excel, pretty soon Power BI, what it'll do is it'll go and download that real server name and connect to that server instead of trying to connect to this, what was put in here. So you can use any HTTP endpoint that returns the text of the real server. It doesn't have to be static. You can make that programmatic. You can decide, you can look at the request coming in. You can decide, OK, I want to send this request to this server instead of that server and just generate the response back. You could also set up a bunch of these across the globe. And maybe in each location you have a different server name there. And you put Azure Traffic Manager in front of it, give your users one endpoint, and that could actually go and then route them to the closest server rather than just going to one server. It really lets you hide a lot of complexity. To make this work, I mean, this is a really, really simple one and a bit of an eye chart. All it is here is it's just an Azure website, and it just returns back to them the server name. So you can make this as simple or as complex as you want. It can actually just be a file sitting in blob as long as you can access it. But this opens up a whole lot of possibilities to let you do all kinds of custom stuff that were not easy or possible to do before. I want to save some time for questions. Some other important features, I'll just kind of glance over them so you can look them up, though, if you want to find more details. Azure Active Directory, we support B2B, so you can have guest users access your models. They don't always have to be in your tenant. You can invite them to your tenant, and then you can add them to your model. They can access it. We now work with the standard on-premises gateway, so you no longer have to install Gateway for Power BI and for Azure AS and for Flow or for Logic App. You can install one gateway, and it'll do all your Azure Analysis Services servers and the other services as well. Firewall, available now, available tomorrow, starting tomorrow. We've added firewall support, so if you want to restrict the ports of who can access your server, you'll start to see that pop up in the UI, and you see a blog post come out on that tomorrow. And that will help you lock down the servers. It's like the SQL firewall, except you let you also narrow it down to only Power BI can access it instead of all Azure services can go ahead and access it, which keeps it a little bit more secure. Real quick, I want to show just a real customer case study, and then we can open up for questions. I want to feature the Azure Intelligence team. This is actually an internal team at Microsoft that they actually do the business metrics and reporting for all the services on Azure. They support the sales teams, the marketing teams. They also support the engineering team. So I look at their data to see how Azure Analysis Services is doing in the market. But they're also a really great use case. They have some big data. They have 5 terabytes of data comes in per day, over a petabyte of data total. They have 900 different pipelines in Azure, over 70 nodes and 1,200 cores to actually go process this data and make it work. One more eye chart for you. If you're using Azure, any services in Azure, you get metered. That data is collected every minute or sometimes every hour, and that data streams into their service. So what they do is they have all the data being emitted from those meters is landing in HDFS. They need something that can ingest large amounts of data, store it cheaply, but also be able to handle that volume coming in. So they use HDFS to actually land that data with Hadoop, and then they use Spark on top of that. And Spark serves as a couple things. One is the seamless integration with Azure ML. They use some of the machine learning APIs to detect anomalies, and they actually send out alerts if there's anomalies in those data. But they also use it as parallel processing. They take that data and they transform it, aggregate it, and start applying business logic to it there. And then they take that output and they ingest that using Polybase directly into Azure SQL Data Warehouse. Never used Polybase before. It'll blow you away. It really moves a lot of data really fast. Once in SQL Data Warehouse, that serves as really their standard data warehouse, their traditional data warehouse. Customers can come in there and pull extracts. They can run much more detailed queries and get a bunch of results back. But for the BI aspects of this, they then turn to Azure Analysis Services to act as that caching layer on there. When every single user goes and hits the DW, right now DW is limited to 32 concurrent queries. One user alone can fill that up, and it's very intense. To get even somewhat similar performance you can get to Azure Analysis Services, you have to really scale that thing up. So what they do here is they put Azure Analysis Services in front, acts as the caching layer, and the caching layer will handle all those BI queries very, very fast, but then takes that load off that data warehouse. So the people who truly need that really detailed data, who truly need to run queries that are not necessarily interactive BI type queries, but are real kind of intense discovery queries, they'll go and run those against the SQL Data Warehouse. So some more information here, the AS processing white paper, which I mentioned before, it can be found here. We have the Analysis Services, Azure Analysis Services product site, which also links to all our documentation, aka.ms/AzureAS. And then we have our blog, which is up on the Azure blog, aka.ms/Azure BI blog. We're trying to at least do one a week. I think we had 2 last week. And we call our new features. We try to give real use case scenarios in there, real how-tos. That's a great place to go if you're trying to get started with Azure Analysis Services or you want to learn about just new stuff that has come out. At this point, if anyone wants to step into the mic, we can open up for questions.
When you're inside the web-based developer, the designer, what's the support for DAX and the function set like time intelligence and those
It's all supported in there. So we have support. Flip back a little bit. We have support for measures, like I showed earlier. We have support for calculated columns. What's missing right now is support for calculated tables. We tried. I thought I was giving everybody a really big place to write large scripts. It's bigger than the other tools, but it's still a tiny little box. So we're going to work on making this editor a little bit better, give you a bigger canvas to work on. We have syntax highlighting in here. You can see the sum was highlighted. We don't yet have autocomplete. That's something we're working on as well. So it'll give you parity with what you have in the other tools. Just we're trying to give you some different dialogues to make it a little bit more efficient while you do it. So the roadmap for these features showing up in SQL Server Analysis Services? Oh, everything's there. For tabular, pretty much everything's there. I mean, it's actually, what's that? Bidirectional cross-filtering is on there. You can actually see it here. You're going to start seeing, and actually you've already seen it, you'll see features coming out first in Azure Analysis Services. And then when we cut a new box release, we'll move them over to SQL Server Analysis Services as well if they can be moved. Right now, we support 1400, which I can still say we did it before SQL GA'd for another couple days. And we're going to have some more stuff soon, too. Any other questions? Azure Data Lake activity. Thank you for bringing that up. I forgot to mention that on the slide. We do connect to Azure Data Lake Store right now. The new connector came out, I think it was last week's blog we announced it. And this is great because what people used to do before is they would create a SQL server just so they could put the data in there, just so they could move it to Analysis Services. So you no longer need to do that. You can actually process the data in Data Lake. Then you can connect directly from Analysis Services to the Data Lake Store and pull the data in. You can also do this with Blob as well. So if you have, if you get the data into Blob Store, you can then go load that also directly into Analysis Services without having to put it in SQL first. Yep. Yeah, the question was, are there any reason you'd want to put it in SQL Data Warehouse rather than just going to Azure Analysis Services? The question is, the answer is yes. If you're going to use it as a data warehouse, there's lots of things that a data warehouse does that Analysis Services isn't even designed to handle. Especially those large ETL processes. We're doing heavy transformations. That is what data warehouse is for. I mean, data warehouse has been around for a long time, not just the product, but the concept. So if you're still doing that traditional role, it absolutely makes sense to put everything in there. If you're just going to create it, let's say someone else is doing the data warehouse and you just need to get it into Azure Analysis Services, if you're just going to create another one just to stage it for Analysis Services, there's not much of a point. You might as well just go to the file. It's a lot easier. You don't have to spin up another server, and just pull from there. Yep. How do you access this from Machine Learning Studio? You have to leave Machine Learning Studio and open up basically open up Azure Analysis Services. So if you're in here, we'll show up as a resource. You can select your server, and then you can actually open it up from here. You can actually open up your model. You can open up the designer from here, or you can open it up, actually just start editing the models directly from here as well, too. I believe it's both. I have to double check, but I'm pretty sure it's both. Mm-hmm. Yeah, so the question is, if you're trying to do more real-time analysis, how does that work with scale-out? Real-time, there's a bunch of considerations. Is everybody in the organization using that real-time data? Typically, most people look at more historical stuff, and you have a group of people who will look at more real-time. If that's the case, it's best to kind of separate the two out, have a model that's updating more frequently, and maybe you don't scale it out. The more you scale out, it's just more physics. You just have to keep copying stuff more and more and more. If you can avoid that by not putting the two together, it makes a lot of sense, and it'll be much easier for you. If you can't avoid that, essentially what you do is you have to put it in. I would still, debatable whether I'd still take out the processing server. I probably would. You wouldn't get blocked by queries in that case. So if you separate out the processing server, you can just keep pumping into that. And then what you do is you just be calling sync more frequently. Now the sync in this is actually pretty fast. And what we do is, if you have, let's say, four replicas out there, we'll take 2 down, sync, warm them up so they're in memory, put them back in, take the next 2 down, sync to them, pull it back up. And actually, it's really just a one-time sync, and we just attach to the 4, so it's very, very quick. But you just keep doing that over and over again. So if you're doing it very frequently and you have 4 replicas, you'll on average only have 2 that are probably running at any given time. You mean a script view in Power BI? On the JSON. I can't speak for Power BI, but I know if you want it there, it's good to put on the ideas.powerbi site and vote it up. Visual Studio, at the moment, we don't have the plans for it. There's some reason we didn't put it in there. I got to double check why it was. I know I've seen it in there at one point, but I think there's some reason we had to take it out. I have to go kind of follow up on that. But we do want to have a really good scripting environment. We spent a lot of time making this. If you've gone from SQL Server 2014 to 2016, you know the object model's changed a lot, and we spent a lot of time to keep that clean, and we want people to actually directly be able to edit that. So we're going to make sure we have good editing experiences for that, whether it's Visual Studio Code, Visual Studio SSDT, the web. You know, we're looking into all those options. Good. Azure what, sorry? B2C. Is there a roadmap for Azure B2C users? What, can you elaborate on how you're going to use it with B2C? Because technically B2C can connect, so you can use live IDs, and you can have technically a different tenant out there, like an application tenant out there. It just goes through the B2B functionality, but it's supported through that. That will work. That'll work today. The difference will be through the B2B support. It will, if you're using like a Gmail account, it will prompt them to create a password. For an MSA account, it'll authorize directly against MSA, and they won't have to create a new account there. But it will work with that email address, any valid email address. Yeah. So the question is, can I have different sources of data in the same tabular model? And the answer is absolutely yes. You can have data from all different places. You can mash them up in the same tables if you want to. You can have them in separate tables. It's a very, very well-used scenario. Can you have a different synchronization or I guess refresh for different sources, different tables? Yes. You have access down to the object level, so even separate partitions you can process differently if you want to. Good question. That's the one exception. So direct query mode is now limited to one data source, mainly for performance reasons. Not the best when you start querying cross servers, cross databases, and try to join across them. But yeah, one source there. Yes, the question is, can you process data into Azure Analysis Services if that data lives in a on-premise data warehouse? Yes, that's why we have the gateway. That'll essentially, you install the gateway, and that will kind of be a proxy through to your corporate domain to Azure AS. I mean, the farther you go, the more hops you go through, there'll be more latency, but we try to make it as fast as we can. Difference between this and Power BI data sets in premium capacity. So Power BI, essentially it's the same technology, right? Power BI is a layer on top of this. What you'll get with Azure Analysis Services, it's like buying a car versus like taking an Uber. One is you're taking an application that takes care of these things for you, but you don't have all the things you can do if you actually had access to that car yourself. So essentially, Power BI will do things for you. This, you're doing everything for yourself. But you have access to all those fine-grained APIs, and you can do all that more details of like going down to an exact partition and processing that, getting a definition out of there, and doing diffs and checking that into source control. All those things, you have access to the full engine here. It's BYO right now for scheduled refresh. With the async APIs, it should be a heck of a lot easier and a lot cheaper too. Just a very simple function app now should be able to achieve that. Especially if you don't check for the status of it and just let it go. It'll be really simple. I was hoping to announce that they're out today. So the way it works is when we finish a feature, it generally takes about 2 to 3 weeks to go through. So I believe it was already checked in, so it should be on that 2 to 3 week kind of train now. Delays happen, so it could take a little bit longer, but hoping by then. Oh, actually, sorry, you were up for a while. When to use direct query or when to use cache. And if direct query works for you, go for it. Like I said, Power BI is very intense. Excel is very intense. Even Tableau also, lots and lots of queries, especially if you have lots and lots of filters on there. When you have high concurrency, even if you think direct query is cutting it for you, when you start to pass that around to more and more users, you're going to put a lot of pressure on those databases. If you have people looking at very similar data over and over again, it makes much more sense to put the pressure on that database once so you can get it into the cache and let everyone hit the cache going forward. I've had a bunch of customers who were able to get direct query to work really well with Azure SQL, but what would happen is they would develop reports. They're supposed to be doing this self-serve, so they have their business users develop reports. Reports would be slow. They'd come back to them. They would go put indexes on the SQL DB, redesign some things, and the report would work great. Then they build another report, and they have to go do it again. So when they put everything in cache, people would just start building reports, but whatever they want. They didn't have to go and make optimizations for every other report. It really got to that kind of self-service that they were going for. Who did I just call on before? With Power Query capabilities, yes. In Visual Studio right now, in the Visual Studio tool, you have the Power Query capabilities. How does it work with partitioning? Very differently than it works in Power BI right now. So if you ever cracked open a Power BI file before, or you cracked open a Power Pivot model before, you would see a connection created for every single table with this really long base64 string in there. We have what we call a structured data source. So you'll create a data source still that has your connection information. If it has a server name, it'll be in the data source itself. Then you can create you can put in the partitions themselves, you put the M queries. We also support shared queries, so you can have shared queries now in the model that then get referenced from each partition. So you could have all your processing logic in one shared query, and in the partitions, just have the filter in each one. Yep. Well, okay, so the question is, if you have a lot of stuff in a Power BI desktop file, a lot of custom M, more complex M queries in there, when you import that to Power BI, will that all be brought in? So now you're getting to the reason why not everything yet is supported for PBIX import. Right now we support SQL, Teradata, Oracle, Blob. We're going to open that up pretty soon to more, but we're pretty soon we'll open up to more. And in a release is kind of starting to finish up, we'll be able to support more of those scenarios better. What's missing right now, so if you have something like that right now that fits at least the SQL, Oracle, Teradata bucket, we will import that. It may not refresh for you right away. You may have to go in and change some stuff up to make it refresh. We are working on making it so we can fully upgrade that and that the structured data source comes out properly, so you can just go to SSMS, set your credentials, and refresh. So the answer is sort of right now. We're getting closer to it, though. Yep. But it will be there. We won't lose it, and you can, with some modifications, manually fix it up. And hopefully very soon, not have to do that. Okay. Well, thanks for coming. Please remember to fill out the evaluations, and have a great rest of the conference.